Welcome back. Today we are talking about Microsoft Mesh, Azure Percept, and other cool things. I don't want to spoiler too much. We are on Fireside Chats, but Delta 3 Innovation Lab. I am Clemente Giorio, aka Tino Tinux. My co-speaker is Gianni Rosa Gallina.
Hello, everybody.
Ciao, Gianni.
Hello, everybody. Welcome to the session.
Both we are R&D Senior Software Engineer at Delta 3 and a Microsoft MVP. And our special guest is René Schulte.
Hi, my friends. How's it going?
Hello.
Hello, René.
Thank you to be here. Before starting with the first point, please introduce yourself.
Yeah, so my name is René from Valorem Reply, where I lead research and innovation around emerging technologies. I'm also a Microsoft Regional Director and MVP for mixed reality, just like you both are, for our friends in the MVP world here, and also an advisor for the global XR, for the XR Bootcamp, as well as for the VR and AR Association. And like in general, working on emerging technologies, things like spatial computing, which some call AR, VR, MR, also AI, computer vision, and also since last year, quantum computing. So covering all these, fancy new topics and trying basically to research what is going on. What can we do with it? How can we make it into offerings and that kind of stuff? Yeah.
So a lot of cool stuff. Okay, now let me check if the streaming is okay. Please comment below. Let us know if the streaming is good, audio is okay. I remember to you that you can interact with us simply leaving a comment. So you can ask something to René, to Gianni, to me. Okay? And of course, if you like, give a thumbs up. Okay, let's check the comments.
Seems everything okay.
Okay. So we start with the first point. René, during the last Ignite edition, in particular during the keynote, the attendees had the opportunity to experience an innovative way of attend a remote event. In that occasion was announced the Microsoft Mesh. Could you tell us your experience during the event? And could you tell us more about this new service?
Absolutely. So actually, let's do it like this. Let's do a little picture-in-picture here.
Okay.
And let me play the keynote, so you can see the keynote here running in the background. Yeah, I mean, like you said, it was a super impressive keynote presentation, because it was not just with Satya Nadella and Alex Kipman, but it was also available in Altspace VR, so you could actually see it in virtual reality, and you could join as an avatar, as you can see here on the video here. You see all these people as avatars, and apparently they're enjoying the content, sending lots of claps and hearts. It was an impressive keynote, like I mentioned. The one really nice thing was for example, before the keynote actually kicked off, I met some friends. They approached me, like I was waiting there before the keynote as a virtual avatar, and then some friends approached, and then we had some conversations with about all the different things, and it felt much more immersive, and it felt somehow like more you would feel connected at a real conference, right? Just at a real conference before the keynote or before a session, you typically also meet friends, and then you just chat away and talk about all the stuff that you expect to come, right? And that also happened in VR, and that already made it much better and immersive than just watching a 2D stream on a website, right? What about you guys? You also joined the keynote, right? What was your impression actually from it? Like in particular, this moment, joining it in Altspace VR.
Yeah, I was there too. We couldn't chat together. Fortunately, we didn't meet, but it was an amazing experience from my point of view. I mean, it impressed me a lot. I attended in past other events in virtual reality, both from using a device and also using just a normal PC. But the immersive level that they reach in Altspace, and especially in the keynote, was very beyond my expectation. I also attended a New Year's Eve concert from Jean-Michel Jarre at VR Chat. It was a good experience, but I didn't feel like inside the world. Instead, of course, there was a different topic. This was a conference. Like there was a concert,
Yeah.
But in that case, in the conference, I felt there, and also it expressed me the level of quality of the graphics, the interaction also, because you didn't mention, but it was interactive, meaning that you could add interact with objects. For instance, all the fishes that you can see there, you could add them just pointed with the controllers.
Right.
And it was very amazing. Yeah.
And well, like you said, right? They had a lot of amazing content. Like you could see it here, like these big fishes. There was also at the end a giant squid, right, which was circling above you, and you could see it in stereo 3D. It's like amazing. They even had James Cameron in the keynote, right? So
Yeah. And you know, when I saw the whale floating around, it's remembered me to the Magic Leap showcase. But it was there. I say I was at in the event. It was amazing.
But in this case, it's a real, not a post-production effect.
Exactly, that's the good point, right? But anyway, also what was fun at the end, they had a wild dance party, right? So you had all those geeks dancing just at a real geek conference. But yeah, no, it was awesome. I had a bunch of fun for sure. Well, and then the big announcement was of course Microsoft Mesh, the new platform from Microsoft. What you can create your own mixed reality applications, right? So it allows you to. So what is Microsoft Mesh, right? First of all, it's a platform allowing to create mixed reality apps that are connected, collaborative, and cross-platform. And here you can actually see a demo. If you want to make that large, maybe that's And so here you can see a demo of the Microsoft Mesh platform that was announced. And one thing to be very clear about, it's not a final product. It's not an end product, but rather a platform that is driven by Azure. And it solves the hard challenges for developers if you want to build like some kind of collaborative application, right? If you want to build something like that, Microsoft Mesh is providing you the building blocks and make your life much easier. So it's this kind of connected, immersive presence, collaborative platform that also is supposed to be running cross-platform, right? Initially, it will be a HoloLens and PC VR, and also, of course, PC desktop. But the Oculus Quest 2 was also announced that this will be supported, and also mobile devices like iOS, Android, and also Mac later on. So basically, you can take all of these devices and then participate together in a collaborative setting, like you can see here in these demo videos, right? You could have local participants that can interact with each other and then bring in some remote participants as well. And that is pretty cool. And basically, it's built on four capabilities, or four key capabilities, if you will. First one is immersive presence, which means you have some really great avatars already built in, which you can customize. But even better, you can also bring in your custom AI rigged avatars. So these avatars, like the animation on all of these avatars, right? You probably know they need to be rigged up. They need to use some inverse kinematics to actually, move an avatar if you move. And this is driven by AI to make it more believable, right? So that you don't have these weird things when you move your hand and then like the arm is behind you, or what you see in other platforms, right? So this is prevented using some really clever AI there. So you can bring in, use avatars and custom AI rigged avatars. And then also the promise is to have holoportation, right, supported. And holoportation is this kind of 3D volumetric video streaming, if you will, right? Where you have these kind of 3D capturing cameras like a Kinect, and then you can be brought into this kind of scene as not just an avatar, but as a hologram, which you can see here in the video. Let's see it. Well, you probably saw it before, right? So there's a point cloud visualization. Yeah, here it comes in a moment. So you have avatars like the lady is on the left side, and then you have these kind of like more volumetric video, holoportation things that are oncoming. And of course, we build our own holographic volumetric video streaming solution called HoloBeam, and we'll see how we can get it in there, right? So this is one pillar, is the immersive presence, like avatars, but also holoportation stuff. The second one is spatial maps. So this is very important because we can use things like Azure Spatial Anchors to persist virtual objects in the real world, right? With the AR cloud, with the augmented reality cloud. That's the big overarching topic of this. What this means is we have all these devices. It might be a HoloLens, but it might also be a mobile device. All of them can do some 3D projection in the real world, right? But what they don't have, or what is missing always, is this kind of connection between it. And the AR cloud enables this with a shared common computer vision map of the real world around us, right? And this is very important because you can then use, with all these devices, this shared common computer vision map of the world, and can put virtual objects here and there and there, right? And all these different heterogeneous devices can all share together the same content, and you can also persist it, right? And that will also be supported with mesh. And I can imagine Azure Spatial Anchors is probably running here under the hood to enable these kind of things. And so Azure Spatial Anchors, the AR Cloud as a theme for this, is very important. It allows us to have world-locked and shared cross-platform and over time virtual objects. Multi-user sync is another one, very important pillar of Microsoft Mesh, because it allows us to have real-time interactions, right? And they actually claim that they will have less than 100 milliseconds delay globally. And this supports pose updates. So for example, if I move remotely, you want to see that my avatar also moves. Or if I move a 3D model, rotate, whatever, the other person on the other side of the planet in this same mesh session also needs to see that very, very shortly without a lot of delay, right? And so this is supported, pose updates, motions, expressions. Super nice, for example, when you try out the demo app with the HoloLens, they also use the eye tracking of the HoloLens, and this will also animate the eyes of your avatar. And only that makes it much more connected with the other person, much more immersive presence, right? And yeah, thanks to multi-user sync. Also, spatial sound is being synced over, so you can hear where a person is talking. If they're standing next to you, you know, okay, like I need to look there, right? These kind of things are enabled with spatial sound. And the fourth one is holographic rendering. And so you can, of course, bring in 3D models with a wide range support for 3D file formats coming. And all of that can be locally rendered, or if you have these large CAD models, they are, of course, not rendered locally, but you can use things like Azure Remote Rendering to basically render that complex 3D model in the cloud in one of these powerful Azure GPU virtual machines, right? And that is possible with remote rendering, basically to offload some of the heavy rendering into a powerful machine, and then having short latency and some clever tricks like late-stage reprojection to actually, stream the rendered frames back into the device. And this is awesome because this enables us much larger models. We don't have to do manual model reduction. We can use photogrammetry models like these complex 3D scans without having to throw away any details. And this will also enable smaller form factors, right? If we can offload some of the heavy lifting into the cloud with Azure Remote Rendering, which was also, by the way, an announcement at the keynote. Azure Remote Rendering is now in GA, general availability, so it's in production ready, if you will. And another announcement was also related to one of these Azure Mixed Reality Cloud services is AOA, Azure Object Anchors, is also now in a public preview. What Azure Object Anchors allows you, similar to Azure Spatial Anchors, where you have world-locked holograms, which you can lock virtual objects in the world with Azure Spatial Anchors. With Azure Object Anchors, you can have object-locked holograms. So you can basically, it can track certain real-world objects, analyze the geometry and all of that, and then show virtual objects on top of that, right? That is also now in public preview with AOA, right? Well, Mesh, impressive stuff. Like I said, we can try out a demo app, a preview mode of a demo app. And this demo application is actually available for the HoloLens 2. And this is called the HoloLens 2 Mesh App Preview application. And the other day, I actually had a demo with one of my colleagues who is based in the United States in Oregon on the West Coast. And I'm here in Germany. And so we tried out the HoloLens 2 Mesh App Preview together. And it was flawlessly. There was no delay. And like I said, the eye tracking was fantastic, right? So with the HoloLens eye tracking, the avatar eyes get animated as well. Feels much more presence, and was really, really fun. And again, we're really eager to get started to integrate custom avatars, which are 3D volumetric video, and we'll see it. Have you guys tried it out yet? Have you met in Mesh? Have you met in Mesh already? Like, what is your impression? Did you get a chance to try it out on the HoloLens 2 Mesh app preview?
Personally, not yet. At the moment, I'm dreaming to try it as soon as possible. And you, John?
No, unfortunately not yet. But I was wondering, so you mentioned that there is a cross-platform way to develop such experience. Which are technologies that we can use? Currently, we already have some SDK available. Which tool can we use to build something similar to the Ignite keynote? Is it already possible, or is something that will be possible in what time frame? Do you know? Have some ideas on that?
Well, do you mean like something like Outspace, or do you mean a competitor to Microsoft Mesh?
No, like the Altspace environment or interactions. Because compared to Mesh, I think it's very difficult now to build something similar. But if you have ideas on also alternatives, so we can discuss about them.
Yeah.
Before starting answering, Christine asking, what's to René, what's your favorite alternative to Altspace?
Well, that's a good, very good question. Well, I've used some other virtual reality meeting tools, but Outspace is definitely my favorite because like this is all where the friends are. You have some good customization option with avatars. It supports a huge environment, and yeah, I mean, there's of course Spatial IO, which we probably tried before, right? That's also great for meetings and so on. And yeah, we'll see how that goes and where it goes. But for sure, for these events, Altspace is great for certain kind of sessions, I would say. Like if you look at these virtual events all over the place, a lot of them are moving into new formats, right? And you have a bunch of different solutions around. You can even use things like Rec Room, right? Or other like more consumer-focused things to meet in VR. And I think these kind of virtual reality platforms are really fantastic for things like a keynote. For a fireside chat we're doing here, that would also be working very well. But for a classic presentation where you're looking at a screen and see some slides and some of that stuff, I'm not sure if you need to do that in Altspace or a virtual reality platform. It's because if you're watching a whole day, you're wearing a VR headset the whole day, I think this is not where we are with the technology now. This is too much cognitive strain on your brain, basically. There's too much. But if you have, these kind of fireside chats, keynotes, or just meeting, right? Like replacing these kind of hall conversations, right? If you're at a conference and then you go out of a session and you meet someone in the hallway and you just network and talk, this is perfect for these solutions because you feel much more connected and immersive. But anyway, once you guys get a chance to grab a HoloLens 2, let's have a meet and mesh.
Of course.
Yeah. Currently, we are experimenting with Quest and VR devices and on other topics related to AI, more on AI side.
Cool.
Another question is, if someone wants to build a keynote similar experience without space, which are the tools, how one can build the capture, the scene, capture the objects?
For example, a Kinect sensor is sufficient for this kind of experience, or it's required a dome with a lot of mixed reality cameras, etc., etc.
Yeah, if you like there are some certain scenes. If you look like this one, this was also from the keynote here. So we have these avatars in the keynote, right? So and what we also have like these avatars, and then you have these people that are volumetric captures. And so I don't know in the keynote if they were actually pre-recorded or if these were real time. But if you want to recreate something like this, like here you can see it's actually a 2D projection, right? If you look closely, like here, these are actually not volumetric videos, but these are 2D, what we call this billboards, right? So you have a texture, and that is mapped onto a rectangle, and basically it's always facing the camera, right? So if the camera, like I'm the camera kind of, and then you have the billboard, right? If I rotate, the billboard always rotates with me, so I always see it in front. That's a good old trick that games used many moons
I
ago.
didn't get it when I was in the Altspace. That's interesting that it worked. It seemed really, the first time I saw the avatars, I thought, wow, they did the point cloud or an avatar mesh there. and sync with some skeletal tracking device like Kinect, I thought.
Yeah,
Instead, there was just a billboard. Interesting.
it looks like a billboard here on the video capture from the event. What we see here when you sit on when you're in Altspace, right? The attendees, they were sitting like here, as you can see, right? So you were mainly seeing it from the front anyway, and the camera, as you see, like in the video recording, they moved the camera up from the ceiling, so this is where you could see it. And so as an attendee, you couldn't see it because you're always looking from the front, basically, and then basically the billboard didn't work for the camera recording they did from the ceiling, I guess. But it might actually also be because, like, when I was in the Altspace, basically, I didn't realize also if I wasn't sure, is it really 3D or is it a billboard? Because like from the distance, it's very hard to see because you're so far away where the stereo effect gets less and less, right? So it's really hard to judge and tell. But in general, I mean, this is also what they want to enable with Mesh, for example, is like you have multiple options. You can bring in these avatars, but you can also have just a quick, maybe mobile phone-based 2D cutout with AI body segmentation, right? And then you can even map it on a 2D billboard, basically, and visualize it like that. And that is actually, a lot of that is believable. But of course, the real deal is getting that into the third dimension, right? And you could use, for example, a device like a Kinect, which in fact I'm using here, by the way, for my webcam and picture-in-picture. You can actually do fun things like this. Yeah, and because I'm using a Kinect with OBS, and there is an OBS plugin, open source plugin, and a great developer added Azure Connect support to it. And so you can actually use OBS with Kinect inside it and use depth-based masking, right? So the certain distance is basically shown, and the rest behind me and in front of me is cut out. And this is how you can do some things like what I'm doing here right now. But going back to the keynote, right? If you want to do things like this with volumetric video, you could also use a Kinect. And in most settings, it's actually totally fine if you just have an easy setup with just one Kinect that captures you in front. Because like what the Kinect will see is basically maybe half of you, right? Something like this. And then the rest of you behind you will, of course, not be seen if you just have one Kinect. But if you add two more, like if you have three Kinects, you have one in the front, one a little angled here, and one there, you can get a full 360 capture. But with one Kinect, you get a 180-degree capture. But again, this is mostly sufficient enough because, like, typically you don't walk around these people all the time anyway, right? You're seeing them mostly from the front, and the stereo 3D effect is still very good if you have a 180-degree streaming. And so you can build some solutions with that. We also worked on our own solution for live 3D volumetric video streaming, and there's a few options available, but there's no, at least I don't know, a ready-to-use product where you can do the same thing as you have seen in the keynote. It, of course, does a lot of custom stuff, I guess.
Great, very, very cool. It's also interesting that we can use a cheap depth sensor to reproduce a similar experience. I agree with you. In many scenarios, is useless a high-resolution 360 avatar, because usually I stay in front of you. I am not going back to you.
Right. You don't walk around with people all the time in the meeting anyway, right? It's like, that would be very awkward, actually, if you would walk around these people. Hey, yeah. Oh, yeah, I always wanted to see you from behind. It's like, hey. But I know you guys are also experimenting with volumetric video streaming, right? So, that is possible with easy setup, even with the Kinect V2 back then, right? But with the Azure Kinect, much better depth sensor, higher resolution color camera. This works, and it's amazing, and you can build things like that. Of course, there's also the offline. I mean, you can use it for real-time volumetric video streaming, right? But you could also have higher fidelity holographic captures, which Microsoft is typically doing with the holographic capture studios, which are not using a Kinect, but like a super crazy setup with a big dome and, like, I don't know how many cameras, but hundreds maybe, or at least a few dozen, like lots of cameras all over the place in the dome, and they do real-time capturing. But of course, there's some post-processing involved, so you get a super high fidelity, full 360-degree 3D volumetric video capture, but it's not real-time, but it has higher quality, right? And for such a thing, like a keynote, you could, of course, leverage that as well. And maybe this is actually what they have done in the keynote, and only the 2D projection we're seeing here is showing us a billboard, right? So what I'm trying to say is, like, although it looks like a billboard on this here, the real deal in the experience might have been volumetric video, but I don't know. On the other hand, if we think about volumetric video, it's of course more resource intensive, right? So like if you want to serve it to many people, you might just want to do it a billboard. So yeah, it's tough. I don't know. I would love to get actually behind the scenes kind of you know, how they built the keynote, for example.
It would be an interesting topic to discuss with them. Yeah, it would be very interesting to know. Yeah, I agree.
If there are any question about this, I will like to jump to.
Yeah, there is one question from Chris.
Okay.
Yeah, René, there are any recommendation for better avatar creators?
Yeah, well, there is a bunch of tools available. Unfortunately, I forgot it. But if you guys know, I can, like, let's put them in the comments. There is a tool, or was it Loom AI? I forgot, but I used it myself. Is it Loom AI? Do you know?
I don't remember. I use but it was 4 years ago, another one. But
yeah, I mean, there are a bunch of great, like more realistic avatar creation tools available. And the one I forgot, but I will send it out later. The one I've used is pretty impressive because you can actually just upload a photo of yourself, and it will use some pretty clever AI to basically map and match a custom avatar and, you know, project your photo as a texture on top of it. But it's also the geometry of the avatar looks quite a bit like you. I forgot the name of it, but it's or was it Engage VR? It could be Engage VR, in fact, where they had this. And so you get more realistic avatars. But then again, you are always, the challenge with this kind of things is, like, you have these avatars, right, that are more comically avatars, like you see, for example, in Altspace. And then you have more believable avatars, or like more realistically avatars, like you could see, for example, in Spatial.io or in Engage VR and these other platforms. But then again, it's sometimes you also hit the uncanny moment, right? It's like they're trying to look more human, but they're actually not really. And then it's missing some of the you know, mimics, and like I said, eye tracking is very important, but also other things. And so it looks very much like you're talking to a dead person, right? This is the uncanny moment sometimes. So there's this fine line where you can get very realistic 3D avatars, but they're not there yet. So you reach this uncanny moment. So I would say rather either go with real 3D volumetric video, like the real thing, right? The real person in 3D, or go with more comically avatars. Because otherwise you have this kind of uncanny valley in between, which is not so nice in my experience when I use some of these tools that have super realistic avatars, or try to.
Yeah, I know there are some research related to that from Facebook for the platform, and it seems very promising. Also, Vive, they are building something. Also, the tools they just announced, they do face tracking, also to have the facial movements, the mouth, to translate in real time in VR. And this is a thing that it will help in the future. Currently, I agree with you. It's better to have not so realistic avatars, but that feel like they are there. So the eye movements, maybe the mouth, it's fine.
Yep.
But then not much more, because otherwise we feel that it's not real.
Right. And this is already, like, if you look at the like, again, like Meet and Mesh, right? We can try it out on the HoloLens 2 and the app preview, which is, by the way, like I mentioned, like, just to be clear, Microsoft Mesh is a platform driven by Azure services in the end, where we all as developers can build our custom solutions on top of. But there is this demo app from Microsoft itself for the HoloLens 2, and if you try it out, it works really well with lip sync. Like you know, when the person is talking, you see the lip sync really nice, and for especially the eye tracking was really impressive, and I feel much more connected. Although it was a very comically avatar, right? But you feel much more immersive present. Yeah, fully agree. And like Microsoft also said, a lot of that is also driven by AI. So as you can imagine, you have some very reduced signals you send over the wire, like some, you know, certain like hand tracking, you know, eye tracking, all of that. But still, you need to interpolate the arm and whatnot, that it looks believable, right? There's a lot of things, and apparently there's some great AI in play here as well.
But the development, there are available some SDK that we can use.
Not yet, but it was announced, Microsoft Mesh. Like the one thing you could do is like go to aka.ms/iwantmr and then sign up as a developer. Basically, if you're not done that already, I know you both, of course, did. But anyway, I don't know like what's the announcement date. There was no date announced when there's a preview SDK available, but of course, we're all eagerly waiting to get our hands on the SDK, right?
Okay, now I have another question. We during the Ignite, we focused also on the Azure Percept. Could you tell something about it?
Absolutely. So Azure Percept is an edge AI solution from Microsoft, which comes as let's say it's more of an end-to-end solution, right? So let me play this here so you see a little bit of it playing in the background while I talk about it. So like I said, it's an end-to-end solution for edge AI. So you don't need to do any custom like module development with soldering, right? Where you typically have to build these kind of modules yourself. If you want to run, for example, a vision service, right? You have a production line, for example, and you want to have some vision AI on site that does, for example, a check for anomalies or certain defects, right, at a production line, just automatically checking. And in the past, you have to build a lot of that yourself, beginning from the hardware into the software. And with Azure Percept, you get a really good basis and a very modular system, which you can get started really quickly. And that's the real benefit is here, that developers can quickly get started without having to build custom edge hardware. And you can also quickly create a proof of concepts. But these are not like throwaway proof of concepts, but they can actually be scaled into production, right? And so Percept solves these challenges to get quickly started, but also when trying to come from a POC to a production scale. And that's really nice. And this is what I really like about it a lot, that it's not just for quick prototyping, but you can actually take the same stuff and put it into production, right? And that is really, really interesting. Of course, this is all integrated with Azure AI and Azure IoT. And then there you can see here in the video these modules. These are the Azure Percept DK, Azure Percept Development Kit, which is basically a modular system with various components that can be added for vision and audio, right? And so here you can see some of that stuff. Here's the audio, for example, the audio board, which you can attach. As you can also see, it has a microphone area with 4 microphones, which allow you to do a localization of audio as well, right? And you can, for example, train a certain AI model that would, for example, detect certain anomalies, right? You might know that, certain experts, when they take a hammer and then they hammer on something like in a production line, a certain thing, they hammer on it, and then they can hear it, oh, yeah, that is broken, right? Or it makes a certain sound, like a rattling sound or something like that. So you could build AI models that take advantage of these audio components of the Azure Percept DK. And of course, the interesting one is also the vision module. So you get a module with the DK that has a camera. You can also attach another sensor to it. I think you can at least two camera sensors to it. And again, you have a very nice modular system. They also have these mounting options, right? You can really mount it in production, and it looks really, really like something that you can use on in a manufacturing line or something like that. And the good part is you get a bunch of pre-built AI models already. So you don't have to create all your AI models from scratch, right? For certain things, certain anomaly detection or, object tracking and all of that stuff, you can have some pre-built AI models. But the nice thing is also this custom vision Azure Percept Studio. So you get, again, like it's a whole platform as well. And you get these development kits, which are currently here in this one. This is made by Asus, but it's an open ecosystem. So everyone can build their own Azure Percept kind of devices, right? And let me see actually where I have the other video. And here you have the vision kit, right? The Azure Percept vision model. And like I said, you have pre-trained AI models, but you can also quickly and easily train your own AI models with it. And that is enabled with the Azure Percept Studio, right? And so here you have these components then you have the Percept Studio, and you quickly create custom vision prototypes by capturing training data with this device as well. And this is really neat. So think about this use case, right? You have a certain production line, you have a certain thing you want to detect if it's in the camera frame, for example, and you can quickly create the training data with this device as well, right? So for example, you could say, hey, camera, take every 5 seconds a photo, and then capture that photo, right? So you have a production line where stuff is moving through. You have the camera, the vision model mounted here, and the stuff is moving through. And then you say, like, every 5 seconds, take a snapshot. Here you can actually see that. And then every 5 seconds, a snapshot. Then you get the data bubbled up in the Azure Percept Studio here. And then you can use that as a basis for labeling your images, right? So here you can see it's taking these kind of training data images, and of course, after you've done that, after you've taken those a few seconds, you need to open it in custom vision. You will see all the images will be populated there, and here you have it. And then you of course need to still label them and provide these kind of labels. What is that, like closed hand and so on. But of course, much easier and much nicer tooling than having to do all of that from scratch without any tooling support. It's much more more work. And so with this here, we can actually gather and collect training data quite easily. Again, also, because the Azure Percept audio component, like I mentioned, can detect certain audio sounds. You can build your own model. Or with the studio, you can also easily create like keyword detections, right? You can enter certain keywords, which will be detected if someone says a certain keyword. And this is also enabled with Azure Percept Studio to build it very easily, in fact. One last thing, which I also find really interesting, is the hardware supports so-called Wi-Fi Easy Connect, which is pretty impressive because, like I said, right, it's not just a prototype, but you can take it into production scale, which means you might need a few dozen or a few hundreds of these devices. And with the Wi-Fi Easy Connect, you can quickly pre-populate these devices. So what you do with Easy Connect, basically, you would then mount all these devices in your production line. You just turn them on, and they're automatically connected to Wi-Fi and will show up in Azure Percept Studio. And that is super nice. And scalability is really well done there. Yeah, that's what I think.
Yeah, impressive. Yeah, I remember back then, just a few years ago, to build something like just you shown the demo video.
Yeah.
Would take a lot of efforts, a lot of people, a lot of knowledge, just from the embedded side, how to build the devices, how to connect them, how to build the OS above, they don't configure it. So instead, you get a complete and full end-to-end platform and solution,
right?
Integrating all the services. Yeah.
And like you said, you guys did actually much more work in that field than I did. And so yeah, I'm love to hear that you also say that as a big benefit of it, that you get an end-to-end solution, if you will, that you can easily customize, but also scale up, right? It's not just for prototyping.
Yeah, usually that was the main issue from blocking projects, because you do the POC, do the prototype with off-the-shelf hardware, or based something custom built, but then you would need to scale. If you start from this solution, as you mentioned, and how the promise they say, you can scale and it will work. So amazing solution that needs to be investigated more and tested.
You guys also worked with Intel RealSense, right? And the OpenCV AI kit, and didn't you? Like I saw it like on social media, right? We're all friends all over the place. So you guys won a competition, didn't you?
It's not just the competition. We didn't just pass the first phase of the competition with using this OAK 3D sensor, which is similar to the real sensor, the Kinect sensor, because you have a depth camera on board, a stereo camera, and the color one. And it's based on the Intel technologies, and you can have the AI running near the camera. So it's similar from some sort to the real sensor, similar to the Percept from Microsoft. It's interesting because you can also build on their custom models, or you can use the pre-trained ones, use, for instance, the Intel OpenVINO solution pre-trained models. And you can download on that and run there. So you just connect it, and it will stream all the data to a client the application that we can build upon.
So this uses an Intel Movidius for AI acceleration, right?
Yeah, it's right. Like the Microsoft Azure Percept, they utilize the same
It's the
AI
same.
accelerator.
Gotcha.
So the good thing is that I can move from my server, my client, the AI computation directly on the camera. So
Right.
a scenario, for example, I can, for example, detect people in a scene directly on the device, and then I can stream only, for example, the face of the people on the server,
Yeah.
then apply on that a more power expensive computation. So it's a more smart way to build end-to-end AI-powered system.
Right. That's actually the benefit we did. I didn't also talk about this huge benefit that you actually have the AI on the edge. Right. That's
Yeah.
exactly what you're saying. You like the benefit. Of course, you can do all of these things with purely cloud solutions, where you have the camera and you do all the processing in the cloud, but you always have latency, right? This is like we're talking about real-time video streaming. There is always some latency. Of course, you can reduce it to some degree, but like this is one point, right? Reducing latency, but also reducing bandwidth if you can take the processing from the cloud to the edge. And this is what this enables. It's closer to where the action is happening, right? So you don't need to send it all the way. You save bandwidth, have low latency. And also another very important point is privacy, right? I mean, this is all secure, right? Azure is the securest, like one of the securest platforms all over the place, right? You can probably never hit the security and privacy levels a cloud solution provider has with your own on-premise solution, because it takes a huge security team, right, to make all of that happen. But still, some companies still say, no, I don't want that video data is being streamed into the cloud. Or, here in Germany, it's like Arbeitsschutz, as they call it, right? For example, like they say, no camera here. Like, they cannot record people and blah, blah, blah. But if you keep it local on the edge, it doesn't go into the cloud. It's all in your own little bubble, right? But the nice thing is exactly like you're saying, these hybrid solutions, right? So I can, for example, take advantage of the cloud for training, right? I can capture the training data locally, but do the actual neural network training in the cloud. And so then I get this easy scale of large machines. I can just use a lot of machines and scale up for the training. And then I can take the trained model and put it on the edge and take advantage of the lower latency there and have the inference, the evaluation running directly where the action is happening. And this is why Edge AI is everyone wants to do it, and everyone sees the benefit of it. And Azure Percept is another tool in the belt, if you will, to enable those easier, right?
Now I would like to jump into another topic. But before talking about the Kinect, I remembered that you shared on social networks an experiment with the Looking Glass. I confess. Okay. You have the view reader. Perfect.
Yeah, exactly. So what are we looking at? So first of all, let's maybe make the bridge between Azure Percept and what we're seeing here. So we have the Azure Percept, right? The AI solution that you have on the edge. And this is using a lot of, it's just using color data, right? It's color sensor, color cameras. And so you can train these models with color cameras. But you also have things like a Kinect, like we mentioned a few times, where you can do like things like here, right? But also a lot of other things. For example, 3D volumetric video capturing. Depth cameras are for these kind of object detection, object recognition, are getting less and less important for these tasks, because there's so much progress with computer vision AI that for most tasks, RGB like color frames are just good enough, right? But of course, if you have more data, if you have depth available, it's even better. And again, you want to use that for example, like 3D volumetric videos, capturing, streaming, and all of that. This is where these depth cameras, like in Azure Kinect, are still there, and they will be for a long time, right? Because they provide us the best quality. Also, in the end, you need to somehow create training data if you want to do a depth estimation from 2D RGB colors into depth. So now let's go to the Looking Glass. So I'm one of the fortunate few people that got into the early beta program for the Looking Glass Portrait. And the Looking Glass portrait is manufactured by the Looking Glass factory or company. And what it is, it's basically a little 3D photo frame. So if you can see it here in the video, it's not that big, right? If you look at my hand, but it's also not very expensive. So it costs $249 at the moment. That's what I paid. But if you buy it later, it will be a little bit more expensive. But what you get with it is a volumetric display in the end, right? So which allows us to see 3D content without having to wear any head-mounted device, right? So you see in the video when I rotate the frame a little bit that you can in fact see all the different regions in 3D. Of course, it has a limited viewing angle at some degree, right? It's too steep. But it allows us to see 3D content without having to wear any stereo glasses or anything like that. And we can just, experience that with our own eyes, no head-mounted device needed. And that is awesome from a few use cases, right? Practical use cases is, like I said, volumetric video streaming without having to wear any glasses, right? Imagine we do this kind of video streaming with 3D volumetric video streaming, and you don't have to put on an head-mounted device, but you can put this kind of frame in the middle of the room or somewhere, and then everyone can see the participants as 3D people for the folks that cannot join on site, right? Which is the default these days. That's one use case. Another one is also we see these amazing progress with mobile 3D scanning, right? I mean, like I have a device here that has a depth camera. Also, the newer iPhones and so on, they all have depth cameras. They can do really impressive 3D scans. And there's a nice tool actually for the Looking Glass where you can take these 3D photos that you take with these devices and put them directly on the Looking Glass. And the nice part about it is this is the new Looking Glass, right? They have been building a few throughout the years. But the portrait one is great because, first of all, it's portrait mode, right? Which works cool if you have people. Much better aspect ratio, right, for humans. It has a little bit higher resolution. It's also much thinner, like the little filter frame on the top, the little filter plane on the top is much smaller. And it looks more like an end product, if you like a consumer product. And again, you get this for $250. You get a 3D display. And the best part is really actually it runs in two modes. It runs in a standalone mode and it also runs in a desktop mode. The desktop mode means you can connect it and via HDMI, and it will show up as another display in your computer. And this is awesome because they have plugins for Unity and Blender and Maya, I think. And so, for example, if you're doing 3D development in Unity, you can basically see the stuff in 3D with this little monitor right next to you, and you can much better experience and see what's ongoing there and can change this. But the best part is the standalone mode. And because there's actually, it's not just a display, they also have a Raspberry Pi built into the Looking Glass portrait. And this Raspberry Pi allows you to, you basically can do some of these 3D captures. Like this is a 3D capture I did with the Kinect, of course, of myself, right? And I can take those also as a short video and put it on the Looking Glass. And then I don't need a computer. It will run standalone. It will basically, you have a 3D photo frame that you can put, for example, at a reception desk or in your house maybe, right? And then greet visitors with a little 3D volumetric capture you took there. But yeah, super great device. I love it because, of course, the HoloLens and head-mounted devices are fantastic, but to be more inclusive and to basically reach everyone, these kind of volumetric video displays are very important because not everyone wants to put something on the head.
Yeah, we're very, very, very impressive. So you can experience that from just a video, but I imagine that from a real person and a real having it is much better, probably.
It's much better because you see stereo 3D with your own eyes, right? But with the 2D video I've just shown you, I tried to simulate it by rotating my phone camera or moving the thing. But yeah, if you see it in front of you, it's amazing. It's like
I remember I've seen similar stuff back then, 10 to 15 years ago, when they're using just a flat TV. And 5 PlayStation 2 connected together to reach the real-time tracing and simulate the different point of view. And now it can run on an embedded device like this one.
Yeah, so it's impressive. Yep.
It's impressive. Yeah.
To be honest, I'm remembering the movie Harry Potter when.
Yeah, it's the same. So you can have your Harry Potter's portrait wherever you want in your house.
Yeah, it's exactly. And the nice part about it, like, this is not science fiction, right? I keep on saying the same thing in my talks, is like, we're living in this amazing age, right, where we're really seeing science fiction technology becoming available. I mean, I have this thing here on my desk. I can hold it up here, right? So, oopsie. Well, this is real. This is well, you can hardly see it, but this is the looking glass here, right? So we're holding a volumetric display in our hand where we could have Baby Yoda talk to us in 3D, right? And that's not just a part of a sci-fi movie anymore. That's real. And it's an amazing time that we can basically see that happening. And this decade will be super impressive because we will see many more things coming out. And also when we look into HMDs, like head-mounted devices like the HoloLens, and all these other devices that are outcoming with smaller form factor, right? They look more like sunglasses. And so we will witness these kind of things, and we will witness as these will reach consumers. And so for us as developers working in the field, I think it's amazing that we can actually change how humans will interact with machines in the future with this spatial computing technology.
The incredible part is that a century ago, that could be imagined like magic. 10 years ago, like sci-fi.
Yeah.
Now it's real. I can't imagine from a year to a century what people can try.
Can achieve, can do,
Yeah. Anyway, we are near to the end of this Fireside chat. If you want to ask something to René, please leave a comment below. But remember that you can watch this video in the future in VOD, because it's free on YouTube and Facebook. So just in case you want in the future ask something to the speaker, don't hesitate. We can answer or maybe reply with another Fireside chat.
Right.
Okay.
Let's do that.
I think that today we saw a lot of cool things. Very, very, very cool. I am so happy. Last check if there are comments.
No questions.
No questions. Usually, or because they are so impressed about the technology, or because the time is not fine.
It's good.
Yeah.
Okay. Okay, really.
All right.
I think that not only Christina would like to buy this screen. I think that after this chat, I will try to buy one.
Yeah.
Gianni, you have the 2 babies, so you need at least 2.
Two of them, yeah.
Yeah. Well, we have 5 kids here in the house. Like it's it's fun. It's sometimes crazy with lockdown homeschooling, right? But no, totally see that. But baby René with meatballs, there we go. That's exactly what we need. You can use some fun filters there to have your own kind of baby face, like with, what was it, Snapchat has this great filter, right, where it looked like baby face. Use it. Now we need to do that in 3D with some fancy AI, and then put it on the looking glass, and then you have it in front of your house, and then you scare all the people away, burglars and so on, to just see that. It's like, oh, no. I love it. By the way, before we close off, maybe one thing to point out, a little plug here. We also have an Ignite showcase page, like on Reply did this kind of thing. And so you can check it out here. What I want to show you is, like, if you go to the Microsoft Ignite, look for this Reply showcase page. And at the end, there's also a session we had there where we had, it's what's called the Internet of Robotic Things, how IoT, MR, and robotics are driving industry, and so on. So you can take a look at it. It's similar style like we just did, like a more of an expert panel, kind of an interview kind of style. And I had my Microsoft MVP and colleague Marek Matiszewski, and also my colleague Justin Jackson, and we talked about, mobile robotics, right? IoT, mixed reality, all of the good stuff. Since we're part of the early access program of Boston Dynamics Spot, like this RoboDoc here, right? And so we talk also quite extensively about it, because it all ties nicely together, right? Computer vision AI, spatial computing devices, because these robots, right, they are actually spatial computing devices on the move, mobile robotics. They have all these sensor data. And now with the ASA, the Azure Spatial Anchors Linux SDK, you can actually also use these spatial anchors, these shared map, not just between mobile and HoloLens devices, but also with other devices, which could be this robot, right? So they could all see the same shared computer vision map with these anchor points, and you can use that for navigation, wayfinding, and so on. Good stuff. Anyway, so like you can watch the session here, still available. Should also have actually a session ID somewhere, but I'm sure you can find it if you look on the Ignite website, where we talk about all of that fun stuff as well, mobile robotics and Spot and what you can do with it.
We will leave the link of that on the comments so that the people can directly click and open the webpage. I would like to thank you to all the attendees. I hope that they enjoyed the session, and I would say thank you, René. Really, thank you. I hope to see you in the future with another Fireside Chat, talking about other cool things.
Yeah, absolutely. Thank you so much for having me. It was a fun experience. Always happy to chat about some exciting, cool, geeky tech stuff.
Yeah.
Okay.
Thank you very much, René. Maybe
Thank
next time in Allspace VR. Why not?
Yeah, or in Mesh. Meet and Mesh.
Or in Mesh,
that's my new
Why
tagline.
not?
Meet and Mesh.
Good.
Yeah, no, I would love to do that. Yeah, let's do it. Thank you so much, Gianni and Clemente, for having me. It's been a pleasure. And yeah, hopefully we'll also see at some point in the real world again.
Yeah.
I hope so.
Have a good day.
Bye.
Thank you. Bye-bye.
Thank you. Bye-bye. Ciao, everyone.
Ciao.